Thanks for staying back with this talk. I appreciate that you made a choice to choose this. There's a lot of buzz going around big data, and when in the morning when Charlie had a slide about big data, I think he's going to already cover the topic, and I'm not going to be left with anything. But I have to tell you that I had very little time to put together these slides, and so you're not going to see any fancy animations the way Nikhil and Abhishek had. But I'm passionate about talking about the stuff that I've been doing. I come here from Singapore. I work for Wiki.com, and I'm really glad to see the number of people in this room, and in general the Ruby community in India, and the standard has really raised. So congratulations to you guys. Someone told me that the standard has raised so much that if your presentations do not reach the standard, that might throw eggs on you. So is there anybody who's got eggs here to throw on me? Because my slides don't look that fancy. So what I did is at least get prepared to receive eggs on me. I went to the restaurant kitchen and I asked them, do you have a few eggs? And I could take that so that my audience can express themselves and give me feedback, negative feedback, positive feedback. So they gave me some eggs, and I actually brought them along with me here. A lot of people think that I was joking, but I have them, and because I don't like the native API of the egg, I've got a Ruby backward eggs here. So people who've already got eggs, the original ones, please hide them aside, and I have these ones. Who would like to have them? Oh, nice, good. And there. And here. Oops. And that's the one. And none of the egg has been broken. Oh, did it break? No, it didn't. So that's great. You guys are really good at catching eggs. Anyway, so
this is the first time I've seen a speaker throw eggs at audience.
Exactly. This is a great opportunity. The first time I got to throw eggs on audience. So if you find anything that, if you find that my talk doesn't reach the standard that I expect, I would love to hear you express that. But if you think that it added value to your knowledge and you learned something from this, do share your feedback. My Twitter ID is @Parolkar. So you can tweet it, you can endorse with this talk or whatever you want. Alright, so I work for Wiki.com, as I said, based out of Singapore. And Wiki.com is it's like YouTube or Hulu of Southeast Asia. So we have a Korean and a Japanese community which is using Wiki.com as their video site. But we're blessed with a community which does subtitling and subbing for the content. So and they also do translation. So content goes from one language to another, especially the Korean TV shows which are very popular in Southeast Asia. They travel, they get translated into English, and then get translated into Russian, and then they go into, open up for a very different and very new kind of audience. So we have been a startup, we have been growing, and we've got to a very good scale right now. We have about 50 million page views, about 10 million people watching the videos in a month, and we have about 2 petabytes of data which is being streamed as a video stream. So part of my job at Wiki is to deal with a lot of this data and build products around that. I have also brought together people from with a similar mindset and people who are working with big data and formed a group called BigData.SG. So you can visit BigData.SG to find out more. And if you visit Singapore, do come to one of our meetups. We have got really good community growing there. And I have been contributing to a couple of projects. These are a few to list. Fluently, I think Matt's specified this in his talk. Fluently was started by Japanese guys, and I think that's where Matt got it. And I have been contributing to Fluently and other projects. Alright, so let's define the buzzword. How many of you have heard of big data before coming to Charlie's talk? Alright, a lot of you. Okay, cool. And how many of you are already working on big data problems? That's nice, about 10%. How many of you are actually in scientific or academic background, like doing some science research and all that? Okay, cool. So mostly the people who are working in big data usually are two kinds of people. One in academia working on things like Human Genome Project, and the other ones are people like people who are internet companies who have got large scale, lot of data to process and all that. So the definition that I like about big data is when the size of data itself becomes part of the problem. And it's interesting because that takes you back to the fundamentals of computing. And you start asking questions like, how do you deal with storage? How do you utilize parallel computing? Whether you work on raw data or you store it in some intermediate structured format for faster query. And everyone has a big data problem, even whether you realize it or not. The people who said we're not working on big data, you are going to be working on it in some time, because if you're part of, say, the lean startup movement, you already know what is the value of insight that you can get from the data that you collect from your users. You already are running some application which is logging something somewhere, and it's just that right now you're not going back and looking at those logs or not storing them for long enough. But going forward, you will be asked, or in fact forced, to go store this data and process them. So I'm sure you guys would have spent some time working on Apache logs to find some user information or some metric that business guys ask. So that's the kind of thing that I'm talking about. People who are, so let's say if you don't have, if you say that you don't have a big data problem, if you're really looking for some interesting problem, then there are a lot of interesting data sets available where you can experiment with. You can go to a Human Genome Project, or you can actually have an open search engine index which is called OpenCrawl. If you go to OpenCrawl.com, you'll find about that. And you can do interesting things with that data and build your own systems around that. So there are two trends which are evolving in big data, and I'm here to talk about how Ruby is being used in this space. Unfortunately, there are not much tools written in Ruby to do this. Java community has been very active in doing stuff in big data, especially things like Hadoop and all that. So there are two evolving trends. One is batch processing, and another one is stream processing. Batch processing is one where you do a post-mortem analysis. You have got a log, a set of logs which are lying somewhere in your archives, and you go back and go parse these 100 GB of logs to find. It's just like going and grabbing this log but in a distributed fashion. Then you have a stream processing where the data is coming to you in real time, and you want to infer some insights out of that all in real time. So there's always tweets coming in, there's always some user metric just coming in, and you are just looking at that, parsing it in real time, and putting it to a dashboard. And they both have different kinds of challenges. So the tools that you have in the stream computing are Storm and S4, and this is still a very new thing that happened to the data world. Storm was released somewhere in towards the second or third quarter of 2011. So a lot of stuff going on, but there's a heavy development going in this space. BigQuery, Google BigQuery is also in beta, which is for batch processing. Okay, so what are the challenges that you face when you have a big data problem to solve? So how many of you understand what a big data problem is? And I've been talking about it. Tell me, like, the people who raised their hand and they said they're working on big data, what kind of problems do you have? Can somebody volunteer? Sorry, yeah?
Data volumes, we see a lot of data coming in.
Okay, so what kind of data is that?
So we pretty much log real-time metrics across performance metrics.
Okay, I can repeat what you say. So.
Yeah, okay. So we kind of log performance metrics, user behavior metrics in real time, and we kind of do predictive analysis of what the user might want to do next.
Oh, interesting. So what he's saying is that they've got some data about user and their usage pattern of the product, and they analyze it and they try to predict what the user is going to do next, right? And Wiki, I also do something similar. I sit at the top of the data, which can tell me what is the trend of Southeast Asian, like viewing pattern of Southeast Asian audience. What are they liking? Or I can tell how the data is or content is being is traveling from one culture to another culture. So that's the sort of insight that you want to get out of the data, and for that you do a lot of complex computing. You do machine learning, you do predictive analysis, and it can be a little more than just doing a simple grep and trying to find counts of some occurrences of some metric. So when you want to build a system like that, these are the engineering challenges that you face. So the first could be the data collection itself. At Wiki, I have a system that has to collect data at the speed 10 times more than the actual app. So if you go to wiki.com and you open a page, that's one page view. But there is a lot of data that's being transmitted for when a person is watching a video. So the player, whether it's on web or on mobile or a TV, we have multiple apps which are distributed on these devices. So there are events playing HTTP calls which are going to tell the Wiki servers that the user is currently starting to watch the video. It's in between somewhere. There was this error. There was from which country, what is the bandwidth and all that. And so for every request, there are 20 more requests, and there needs to be a server or system which can take that data. So if page views on Wiki is 50 million, you can imagine it's divided by, well, just multiply it by 20, and that's the scale that I have on the collector, which is collecting the data. Then you come to filtering and segmentation. So how do you filter? You cannot work with raw data all the time. So how do you filter, how do you segment, and how do you then store the data optimally so that when you want it, you have it. Then you come to the real game of analysis, where you apply some scientific algorithms to get the information out of your data. And then of course the visualization and do prediction and extrapolation and all that. So Fluently is the tool that I use for data collection. How many of you have heard of this before? No one? Okay. Matt, I was surprised that Matt actually spoke about it. It's very new, and when I started working on this, it's written by a friend of mine. His name is Kazuki Oda from Treasure Data, and it's a very, very interesting tool. There are different. This is purely written in Ruby. So before this, people used to use called statsd, which is from etsy.com, written in Python, and in fact, 27 people also use statsd. And The reason I chose Fluently was because it has a very plugin-based architecture. So you could hook multiple streams and you can control almost everything possible with collecting data in Fluently. So the good thing, the basic thing about Fluently is that it treats your logs not as files but as live streams which can be filtered and forwarded. So I have solved two problems. One is my data collection and then the filtering and segmentation by just hooking Fluently to my system. So you can see that Fluently is the entity which sits in between your log streams, and so you can define, so log can come from web apps, your log, Verilog, Apache, and it goes to files and email, go to S3, send it to another Fluently server, send it to Splunk, and all that. So the way you use Fluently is pretty straightforward. You have plugins for inputs, you have plugins for outputs. So you choose where is your from where is your incoming stream coming, and then where you want to store your stuff. So what you see over here is something that mimics Google Analytics. If you look at Google Analytics request, you will find that Google Analytics makes requests for image every. So when you include a small snippet in your pages, it's after every minute, after 5 minutes, it's going to fire a request, and it requests for an image with the query parameters. So the query parameters will be actually the data that Google is receiving for you, and this is to mimic that behavior. So let's say you have, so you send events as a namespace and key values, and it returns a GIF image. That's what my source tag specifies over there, and then you map it to two things. So I'm sending that stream to S3, and I'm using something called Splunk. Splunk is a tool, a hosted tool that allows you to analyze your logs in real time. There's a company called Splunk, and they have a tool called Splunk Storm, so you can go explore it more. So you receive this data in. So you receive events as a simple HTTP call query parameters, and Fluent forwards it to the next entity as a timestamp, namespace, and a semi-structured JSON. So it's a semi-structured data. And another reason why I use Fluently is because I have modified Fluently to be able to run on Heroku. At Wiki, we run everything on Heroku. All the scale that I'm talking right now is on Heroku. So Fluently can scale with, how many of you are using Heroku here? Introduction. Oh, that's nice. So I have this application which takes Fluently inside, and it runs on every dyno. So I could just increase the number of dynos if I know that my number of requests are going to be increasing. And the good thing about using Heroku is that you don't have to worry about a big request log, and you don't have to worry about load balancing. So you hook a Fluently because you actually are receiving a lot of data, really. So if you don't want to use set up everything in your boxes on your hardware, just go use Heroku for good scaling of Fluently. I have done a small screencast, so you can take down that URL and then visit it and learn more about how I use it on Heroku. It gives you a step-by-step approach of how this entire thing works. Coming to storage, there are no Ruby tools which are doing this. Hadoop has done a good job. It's written in Java, and Java community has done a good job of building this entire thing. So I rely on, and a lot of people rely on Hadoop HDFS for storing the data. And there's also an interesting thing called OpenTSDB, which is a time series database. Again, this is also not Ruby. OpenTSDB stays on top of HDFS to optimally store time series data. And then there's something called SciDB, which they call data management and analytics system, something like that. It's more like a scalable SQL or relational database. And people who talk about big data usually don't talk about relational databases because the obvious reason, everybody knows what that might be. But SciDB is actually from the guys who have done Postgres, and it's interesting that they are trying to fit SQL kind of thing in the data world. So I haven't used it. If you use, let me know. If you want to try, give me a feedback. Let me know what you got from that. And then you come to the analysis. So the thing that Hadoop has for analysis is Hadoop streaming, and there you write pure Ruby scripts. How many of you have done some kind of MapReduce? Nice. MapReduce is something where you divide and conquer. So you have something to solve, you divide the problem into small pieces and map it to small partitions and then reduce it to a single result. And Hadoop has a good framework to do that. But you have to specify the map and reduce step, and that can be specified in Ruby, and that's what I also do sometimes. But this means that you have to think about solving your problem in MapReduce. So go back to the basics, learn about MapReduce and how you can write these the two steps. There are frameworks which have been written in Ruby to allow you to do that. Wukong is one of them. But there are not very famous tools that people usually just use Ruby, pure Ruby scripts to define MapReduce. Another thing is Hadoop Hive. Hive gives you an SQL-like abstraction on MapReduce. So you want to, let's take an example. You have got a log which has requests for every page views, and you want to find out how many unique users you have. So when you want to build a system like that, you would create, you would have logs, you just go grab logs and find out the column and just group by the metric that you have. And Hadoop Hive, what it does is that it allows you to ask that question as SQL. So you could define that if my request log has X columns, I could just write an SQL query and say, where X is equals to this user, give me all the logs. And that is possible by Hive. You can use a tool called RB Hive that integrates pretty well with Hive servers. So you hook a Ruby script that, so RB Hive is just a tool that allows you to interact with Hive, which is a self-contained framework. About the visualization, well, everybody has their own visualization need. We have built our own custom dashboard with Rails plus Google Charts. You guys can use BigData or any fancy thing to build. So there are two things for visualization. You would have to, one, store the data for faster access. So if you build a dashboard, you probably have some filters on that. So you would need to have, you cannot always go to Hadoop to do the big data query for all the requests. You have business users who are coming and looking at your dashboard and they want to just quickly get some information. So you need to have intermediate data, and that is stored in your Rails app, in your choice of database. So you've got to build it on your own most of the time. But there are tools like Tableau Public, EcoBoard, Splunkstone that helps you do that. So that brings us to stream computing. And Storm is really, really new, as I said. And it's mostly for the people who are working on real-time. Not everybody needs real-time computing, really. So 90% of the time, they just require some post-mortem analysis, and that's good with Hadoop. Storm has a very different terminologies than Hadoop, and these are stream, spout, boards, and topologies. So when if you want to work with, again, this is Java, but we have some Ruby wrappers around Java so that it at least gives a good feeling that you can go to JRuby to interact with Java and then write your stuff for Storm. So let me define these words for you. Streams, it means any flowing data. Spouts are the entities which emit the streams. Boards are the entities which process the data. And topology is the entire network. So you can think of a Storm application as a topology, which is like a network. So from one side you have some incoming logs, and it does some stuff inside, does some computation and reduction. And then you have the logs, the result at the other end. And it's running all the time. So when you run Storm application, it's a job that's running all the time. In case of batch processing, you request for data, you run it for some time, and then just finishes. So, good news is that Red Storm is there, which helps us interact with Storm in Ruby. It's a JRuby thing, so you just grab JRuby, bundle install Red Storm, and just get set up working on your machine. It's pretty stable. Like in terms of the installation process, it's pretty easy as compared to other technologies in Hadoop. I wanted to actually give you a demo here for Hadoop as well as for Storm, but it's a little cumbersome. Like it's got a lot of pieces to assemble, so it's a little hard to do that kind of demo in like 45 minutes talk. So I want to talk about an experiment that I did, which is not really used in production, but it's something that I was playing with at wiki.com. We wanted to figure out the average bandwidth experienced by our users when they're watching the videos, because that tells the experience of users from different geography. And we wanted to have like a dashboard in our database on a big screen which could just rotate it and tell us what's the status in Korea, in Japan, in other parts of the world. So that is wiki.com sending some data to the log collector, which is fluently, and that goes to the Storm, which has these entities, and then goes to the dashboard. So the way you do it is you get lat long, which is the geography of position, and you get the bandwidth of the user with that, and our Flash player can send that because they're downloading the data, so they know what's the bandwidth of the So Flash player sends this information all the time, every 5 minutes, and that gets collected somewhere. And we get this data which then can be worked on. So there are these different steps that you go. You cannot you get data from all the places, but you cannot just hook all that into the map. I'm talking about the visualization. You cannot put it on a globe or a map to just visualize, because you need to. That's a lot of data. It's more than you can imagine. So you have to do some reduction, some average, try to locate the points, and that's where you have this algorithm where you just get the information like lat long, kbps speed, then you rank or score, give a score to that bandwidth. So you can see that I have some records 100. So anything between like less than 300, give them 1. After that, give them 2. Anything more than 600, give them 3. And then you group those points together. That's called a clustering step. And then you reduce, which means if there are 2 points which has same bandwidth, then probably you can reduce the point on the map. So you would just select one out of the, or just one average of the bandwidth, because there are so many people here, there are so many people who are using your application. So you have 100 points being collected. You want to reduce that to a single point on the map. And then you have a dumping step, which converts your bandwidth into a magnitude so that you can see the stuff on the globe properly. So how do you do that with Ruby or Ruby? It's hard to get into details of this in a small talk like that, but So this is how syntax looks like. You have redstone simple spout, which is given to you. You just have to extend, make use of that, implement some method, and that's it. So you define what is your output field. So this is a spout which is supposed to get the data from somewhere and then become the entity which emits the streams to other stuff in the topology. So in my case, I have Fluent Reader, which is like a TCP connection to one of my Fluent machine, and Spout gets the data and then puts it into my @queue, and then whenever the boards are ready, they keep getting the data from here. Scoring step, well, it's a bolt because it has to do some kind of processing. So you have bandwidth ranking board. You actually call it bandwidth scoring board. And as you see, you specify what you do after you receive that data. A tuple is the record that you receive. And then you convert that into, you parse, and you convert it into array, specify rank, bandwidth, background. And then you have a clustering board which does almost similar things, but it has to wait. So if you look at this, the return from in my on receive is a record. It's an array with rank, bandwidth, background. But in the other case, it's there is no such thing. There's something called unanchored emit, which means the clustering step needs to wait. It has to get all the records and has to wait for some time before it can, because it has to send a set. So unless you have received enough records to group, you cannot send it to the next step. Then you have points reducing. Again, it's a similar thing. And then the dumping board, which is going to receive all the data and wait until you have enough records to be plotted on your visualization tool or on your globe. And that's it really. So this is how you hook the entire thing into the topology. You specify what is your spout, you specify the class, spout class where you specify your boards, and then that's it. You specify the entire. So this is the representation of this box. So where you have spouts sending to ranking board sending to clustering board, reducing board, and then dumping board. So that sequence is programmatically defined with this. Alright, so that's all about it. I have an interesting newsletter where I share about my experiments and stuff that I'm doing. These days I am actually exploring using GPUs for parallel computing. So if you guys are interested, I'll be happy to share my stuff with you, and if you want to join any of my open source project, you're welcome. So please do sign up for my newsletter if you're interested, and visit BigData.sg. And thanks a lot for being here. So any questions? Yeah.
Thanks for coming here. My first question is, does Fluentd supports like kind of crawling stuff? Secondly, does it support to store the data in relational databases?
Okay. Question number one: does it support crawling? Crawling is not the problem that Fluentd is supposed to solve. So, the job of Fluentd is to just get the data in, so receive data. So no. So answer to your question is no. It cannot support any sort of crawling. The next question was, I'm sorry. Okay.
Does it supposed to store the data in relational?
Okay. Yeah. So yes, it can support. It has plugins. So there are a lot of people who are writing plugins. I don't see a reason why you would go and write this sort of data into a database, because it's just too hard to maintain that. you're talking about billions of records. So, if you have a small demo app, or if you're at a very early stage, probably you can hook a plugin which allows you to write this data into a database. But going forward, you usually would not go. If you're using Fluently, you actually already have passed a step where you are, like, there was a time when I used to have, like, didn't require this Fluently kind of stuff. You could just have Apache running somewhere and just get the logs of the regular Apache logs, and then just parse over that or store that into the database. But when you start to grow, then you face scaling problem, and then you go to Fluently. So I haven't seen anybody using SQL for the storage for that.
Yeah, if you just go to your previous slide, architecture slide.
Architecture?
Something you shown on.
This one?
Yeah, no, down here.
Earlier. I think this because
somewhere there was web apps and logs you were collecting fluently.
Oh, okay.
So what does it mean, like web apps coming to the fluently? What exactly?
Okay, good question. So this is a page which is like Google Analytics. It's making a request all the time to your server. So you have some data to transmit to your server. You just create a simple JavaScript tag or make it Ajax. You cannot use Ajax because it's a cross-domain thing, so you want to avoid that. And you make a request to your server. People usually use, like, they host an image somewhere on an S3, and when they want to just collect the data, they just make a request to just create an image tag hidden in your body somewhere. And when you do that, the browser will make a request to get that image, which is going to be a blank image. And the S3 logs will have the entire URL, the data. So you could go to S3 log and see all the query parameters. That's your data. So that's what I mean by that.
Hi, thanks for all the insights. Just one question I have is about Tom. Can I compare that with cascading topology, where we have pipes and sinks, where you keep on computing? I mean, it's a wrapper on top of MapReduce. Storm internally does the MapReduce?
No. So okay. So cascading is, so the author of Storm was actually doing cascading before, and so he started finding some limitations. So Hadoop is actually, or cascading in Hadoop was actually meant for, it is designed to do batch processing, right? So there are certain issues that they started facing, and then they said, let's do something, let's build something especially only for stream computing.
So data in motion, basically.
Data in motion.
Instead of doing analytics on data in store, I mean, you are doing it
exactly.
data in motion.
Hey, I'm Nikhil from yourmixing.com. We are building a recommendation engine, and it's a product startup, and we are now set to accept data from the user. So it would be granular data, consisting of some user details. Like it won't be the nature of the data won't be like a log or something like that. It would directly relate to the user's attributes. And we are, like you mentioned, that RDBMS falls short of performing such operations. So we are using graphs for that. We are using a graph database. So my concern was from the storage perspective. Like you mentioned, that HDFS is one option. Is there a solution available out of the box that can support graphs and the traversals using batch processing?
Neo4j?
Neo4j is one, but that gives you an HA cluster. But there are certain limitations with it. We are right now using a Neo4j community edition, and already facing issues with a large amount of data going in. So we are planning to scale it up, but with a community edition, all you are left with is a vertical scaling. You cannot really scale it horizontally. You need an HA cluster for that. I was coming from a perspective where we even thought of using HDFS some time back when we were into classifications. So So we wanted to classify user data, and we were considering SDFS, but then we checked that because it would have been an overkill because right now we don't have that much of data with us. But soon we are looking at a huge amount of data flowing in the system. So I just wanted to know something about graphs.
I have only heard about Neo4j. Sorry, but I'm also exploring this area, so I share the same state with you. Let's find it together.
You mentioned about the plugins which people are trying to build over Hadoop. Right?
Or fluently.
Okay, over fluently. So, I was curious if someone is working towards taking data directly from graphs.
No, I don't know anybody who is working on that kind of stuff.
Okay.
Thanks.
Hi. Yeah, I just wanted to ask you one thing. See, in case if you're really fluently to source from multiple sources, then it can come from LinkedIn, Twitter, or it can actually be a logs. The storage option could be either HDFS or it could be a NoSQL database, which would be the ideal one of these two. Now, on both of them, you can use MapReduce or Hive in case of Hadoop, and then get the results out. So, what is the right scenario in which Hadoop should be used of the NoSQL database like CloudDB or Dynamo or say DynamoDB can be used? How would you basically differentiate between storages from a MapReduce between HDFS and a NoSQL database?
That's an interesting question. So, the basic philosophy of Hadoop is that it usually works with plain raw files. So HDFS is just a file system, right? And you have this log file which are partitioned by some date or some user metric, and they're just plain files on file system. So you read files, give it to a node in the cluster, and process it. It's pretty hard to, as I think Charlie mentioned something in the morning. He said it's important that if you're working on this kind of problems, there are two ways to think of it. If you want to think of parallel computing, if you want to reduce your challenges that you're going to face, then keep the data and the compute together. Right? And when you work on something like HBase, or when you work on a database or where you have another level of abstraction, not just a raw file system, then you would have to do a lot of transfer between the nodes. So the way I think about it is, if you have a lot of data which can be stored on the file system directly, go with Hadoop, go with just work with plain files all the time. That you will reduce the complexity in the entire picture. But there are scenarios when you have to go next level higher. You cannot just work on plain text file. It's just too much of time, too much of resources. Then you start storing data in intermediate form, and that's when you start to evaluate these tools and then choose the NoSQL database. So that's how I can answer your question. Does it make it clear?
So in that case, you would actually prefer to store some reduced version into the NoSQL database. You would actually prefer to store the reduced form into your NoSQL databases.
Exactly.
That is better.
Yeah. That's how the usual pattern. Like I have raw data in Hadoop, and then reduce the final insights go into some sort of database, relational or NoSQL.
Hi, here one question. Can Storm replace Hadoop because we are already running with Hadoop? So is it production ready, or can it replace Storm or something like that?
They both solve two different problems. They solve two different problems. So you cannot really use Hadoop for Storm for the same reason for Hadoop. For Storm, you need the data all the time as a real live stream. So well, my answer is no. They are just two different things. Any more questions? What?
that was the license.
Thanks a lot.